Now, we're going to discuss how to balance a redox reaction. So first is in acidic solution or an aqueous solution. So the method we're going to use is the half reaction method. So here we have 5 steps. So first, write a separate equation for the oxidation and reduction half reaction. Second, balance the half reaction by following this series of steps. So first, balance all the elements except for hydrogen and oxygen. Then, balance the oxygen by adding hydrogen, H2O or water. The next, balance the hydrogen by adding hydrogen plus. So hydrogen plus, by adding this, we're making our solution more acidic. And lastly, balance the charge using electrons. So third step, if necessary, multiply one or both balance half reaction by an integer to equalize the number of electrons. So transfer in the two half reactions. So first step, add the half reaction and cancel all identical species. And lastly, check that the elements and charges are balanced. So let's have an example. So balance this reaction between permanganate and iron in acidic. So first thing we have to do is to assign the oxidation number. So for permanganate, we have -2 for oxygen. Since we have 4 atoms of oxygen and a net charge of negative, so the manganese have an oxidation number of +7. Iron has +2. And at the right side, iron now has a +3 and manganese has +2. So to help us to memorize easier the definition of oxidation and reduction, we just need to look at the third letter. So for oxidation, we have I, meaning we have an increase in oxidation number. And for reduction, letter D, for decrease in oxidation number. So in our redox reaction, manganese at the left side has +7 and at the right side now has a +2. Therefore, this is our reduction half reaction. And as we could see in the iron, we have +2 at the left side and +3 at the right side, meaning there's an increase in oxidation number. Therefore, this is our oxidation half reaction. Now, we'll proceed to the second step, which is balancing each half reaction. So let's go first for the reduction half reaction. So at the left side, we have a manganese of 1 and oxygen is 4. At the right side, we have 1 manganese and 0 oxygen. So the first thing in balancing half reaction is to balance elements except for oxygen and hydrogen. So since manganese is already balanced, let's proceed now to oxygen. So at the left side, we have 4 oxygen. So we need to add at the right side 4 water or 4 H2O. So now, we have already balanced the oxygen. But we have additional elements, which is the hydrogen with 8. So to balance hydrogen, we need to add hydrogen plus at the left side. We're going to add 8 hydrogen plus to balance the elements. Okay, so now we already balanced all the elements in both sides. So next, we have to look for the charge of each side if it's balanced. So for left side, we have 8 plus for hydrogen plus, and for manganese, we have 1 minus. Therefore, the charge for the left side is 7 plus. For the right side, we have 2 plus for manganese and 0 for water. Therefore, our oxidation number or the charge for the right side is 2 plus. So we need to add 5 electrons at the left side to balance the charge. So plus 5 electrons. So that we have now 5 minus, 8 plus, and 1 minus. Then our oxidation now, the charge now is 2 plus. So we have already balanced the reduction half reaction. Now, let's proceed in the oxidation half reaction. So first, we have to balance the elements. At the right side, we have 1 iron. At the left side, right side is also 1 iron. So all elements are already balanced. So let's check the charge. So we have 2 plus at the left side and 3 plus at the right side. So we're going to add electrons at the right side. Just 1 electron will do, so that the charge at the right side now is equal to 2 plus. So this is our balanced oxidation half reaction. Now let's proceed on the third step, which is to multiply integers to balance the number of electrons at each half reaction. So since in reduction half reaction, we have 5 electrons, and in oxidation half reaction, we have 1 electron, we need to multiply the oxidation half reaction by integer 5. So now, our oxidation half reaction is 5 iron, 2 plus arrow, iron, 3 plus, plus 5 electrons. So we're just going to multiply or distribute the integers at all elements in this half reaction. Okay, so since we have already the balance half reaction, reduction half reaction, and oxidation half reaction, let's proceed at the third step, which is to add the half reaction. So we're just going to write all the elements. We're just going to combine the two half reaction. Okay, then we have to cancel all identical species. Just like in equation in algebra, if we have two identical elements at both sides, we can cancel that. So since we have 5 electrons at the right side and left side, we can cancel this one. So now our final balance redox reaction is 8H plus manganese, oxygen 4 minus plus 5 iron 2 plus arrow manganese 2 plus 4 water plus 5 iron 3 plus. Okay, so last step, let's check all the elements and charges if they are balanced. So we have here hydrogen of 8, manganese is 1, oxygen is 4, and iron is 5. At the right side, we have hydrogen of 8, manganese is 1, oxygen is 4, and iron is 5. So all the elements are balanced. Let's proceed with charge. So we have 8 plus, 1 minus, and 10 plus. So the charge at the left side is 17 plus. At the right side, we have 2 plus, 0 for water, and 15 plus. Therefore, our charge at the right side is 17 plus. Okay, therefore, our final answer is correct. We have balanced all the elements and charges in this redox reaction. Okay, so now let's have balanced redox reaction in basic solution. So in this method, you just you're just going to add some step from the first method in acidic solution or aqueous solution. So generally in doing basic solution, balancing redox reaction in basic solution, we have to do all the steps in acidic solution. Then from that final solution or final balance equation, the H plus ions were present. That's why it make acidic. Now, we need to eliminate that H plus to make it basic by number 2 step, adding both side hydroxide or OH minus. So hydroxide will make our solution more basic. Then by adding hydroxide, we can eliminate hydrogen plus ions. So if when hydrogen plus and hydroxide is being combined, it will form water. And at the third step, the formed water that containing both positive and hydroxide ions, that containing both hydrogen plus and hydroxide ions will be eliminated. We will eliminate the number of water molecules. Okay, so and the last part is check the elements and charges whether they are balanced. Okay, so are you ready? So let's have our first example, second example. So this time, using the same redox reaction from acidic solution, this time we're going to balance this use by getting the basic solution. So as I have said, just do the step already stated in the acidic solution. So we already have our solution, or we have already have the balanced redox reaction for this equation, which is 8H plus permanganate plus 5 iron, then arrow manganese 2 plus 4 water, then plus 5 iron 3 plus. So our objective is to eliminate this hydrogen plus by adding hydroxide at both sides. So let's add hydroxide. So 8 hydroxide, so that when we combine this with the hydrogen plus, we're going to have 8 water. Then at the right side also, we're going to add 8 hydroxide. Okay, so now let's combine hydroxide and H plus. So we have now 8H2O with 0 charge plus manganese O4 minus plus 5 iron 2 plus. Then we have manganese at the right side 2 plus 4 H2O plus 5 iron 3 plus 8 hydroxide. Okay, so third step, we have to eliminate the water being formed in our equation. So since at the right side we have 8 water, at the left side we have 8 water, and the right side we have 4 water. So we can eliminate this one by 4. Okay, so now we have for H2O plus permanganate with negative charge plus 5 iron 2 plus arrow manganese 2 plus 5 iron 3 plus 8 hydroxide. Okay, so let's check all elements if they are already balanced. So hydrogen at the left side is 8, oxygen is we have 8 oxygen, manganese is 1, and we have 5 iron. At the right side, our hydrogen is 8, oxygen is 8, manganese is 1, and iron is 5. For charge, we have 0, 1 minus, and 10 plus. Therefore, the charge at the left side is 9 plus. At the right side, we have 2 plus, 15 plus, and 8 minus. So 2 plus 15, 17 minus 8, we have 9 plus charge. Therefore, this is our final, this is our balanced redox reaction in basic solution. Okay, so guys, let's have your check your understanding. So this balance equation, first by acidic solution, then do it now for basic solution. So you're going to have a two balanced redox reaction for this check your understanding.